The purpose of this video is to go over question 29 on 1.5, and I want to highlight the definition of continuity that's in the book. And so if you go to your book, the very first thing in 5.1 is three things have to happen for a function to be continuous at a point. It has to be defined, and the limit on the right has to equal the limit on the left, has to equal the value of the function at the point. So this is in your book, and these three things happen. So mathematically what that means is the limit on the left has to equal the limit on the right, has to equal the value of the function at that point. So in these two problems, you're solving for the k that satisfies those three conditions. So mathematically, since these are both polynomials, they're continuous everywhere, so the only point we have to worry about is at the jump. So we have here the limit as x goes to 1 on the right of the function equals the limit as x goes to 1 on the left of the function equals the value of the function at 1. So if I look at the limit on the right, that's going to end up being 10, 1 minus 8. The limit on the left is going to be k to the first power squared equals the value of the function at 1, and the value of the function at 1 ends up being 10x minus 8 when x is 1. So this is going to be 10 times 1 minus 8. So I'm solving this equation for k. The same thing down here, but be careful, the point of discontinuity that happens here ends up being 2. So I do the same thing except the limit on the right and the left and at the function is at 2. So here I end up with, I'm going to go ahead and write this out, the limit as x goes to 2 from the left of the function equals the limit as x goes to 2 from the left of the function equals the value of the function at 2. So here the limit on the right of 2 is going to be k, and this time my x is 2 squared, equals the limit on the left, I'm sorry, I did not do that first. Let me erase this. The limit on the right is when x is greater than 2. So I'm looking at this function. It's going to be 8 times 2 plus k equals the limit on the left, which is going to be when x is less than 2, right? It's going to end up being this function. That's going to be k x squared equals the value of the function at 2, which ends up being that same formula. So I'm solving 16 plus k equals 4k. So I solve algebraically for k here for my answer, and I end up with 10 minus 8 equals k. So I solve algebraically for here for my answer. So hopefully this answers your question on 29 on 1.5, and there's another problem on Wiley 29A, the tutorial problem that kind of walks you through that. Please keep me posted if you have any other questions.